So good morning, good afternoon, good evening to everyone, and welcome to the CESRA Talk on key soil issues in Southeast Asia. Southeast Asia faces growing soil challenges that threaten food security and sustainable development. Key issues include erosion, acidity, salinization, nutrient loss, and contamination, driven by both natural and human factors like unsustainable land use and climate variability. Today's talk highlights the biophysical and socioeconomic causes of soil degradation across the region, with case studies from Thailand, Vietnam, and Indonesia. It explores impacts on agriculture, water resources, and livelihoods, and introduces sustainable solutions such as conservation agriculture, digital soil mapping, and community-led restoration. Today's expert on stage is Assistant Professor Dr. Wanwisa Pansak, a senior researcher at Mahidol University, specializing in soil and water management. Dr. Pansak holds a PhD in agricultural sciences and degrees from Naresuan University. Her experience includes nutrient cycling, water quality, stable isotopes analysis, and erosion assessment. She has published 22 articles, 2 book chapters, and leads research on sediment delivery in reservoirs. Dr. Pansak is a counselor for the World Association of Soil and Water Conservation and has received awards including the Franco-Thai Cooperation Program and Best Poster for Climate Change Research. Not last, she's a member of the CESRA Technical Committee. Dr. Pansak, thanks for joining us today. We are honored to have you with us. I'll now hand over the floor to you for your presentation, and following that, we will open the floor for questions and a group discussion. Over to you, please.
Okay. Good morning, everyone, and thank you very much for being here today. And first of all, I also would like to thank Lucasia for the introduction. And I also want to thank CESRA for allowing me to join the work as the member of the technical committees and also to contribute to the second webinar today. And today I will pleasure to share with you a presentation on the topic of key soil issue in Southeast Asia. In this talk, I will provide first with the introduction on why understanding the soil issue is critical in Southeast Asia. And after that, I will talk about the key soil issue in Southeast Asia, include with the driving factors of the soil degradation, some case study from the selected country, and also it will include with the strategy for the sustainable soil management, and then will be talk about further perspective and recommendation. And at the end, I will open for the floor for the question and answer. And I hope this topic will be interesting and useful for all of you. Okay, let's begin by understanding why soil is important for agriculture, ecosystem, and climate. In the agricultural perspective, I think everybody knows soil is a foundation of the crop production and it provides the essential nutrients, oxygen, and water for the plant growth. And soil normally support about 95% of the global food production. And soil also normally play an important role with the ecosystem. And you already, I think here it's several times, soil is a big habitat, about 25% of the world biodiversity. And soil also support with the microbial activity, decomposer, and nutrient cycle. Soil also is very important that involved with the climate regulation because soil is a significant carbon sink and also is helped to reduce the greenhouse gases in the atmosphere. And also is influenced with the water flow and also involved with the water cycle. Therefore, nowadays, the issue about healthy soil is getting popular or in the issue that we need concern. As you already see, healthy soil are the fundamental of the life, and soil degradation also can impact with the agriculture, ecosystem, and also with the climate system. Therefore, the Southeast Asia country, you already can see is play very important role in the global food security with the key contribution in consisting of first with the agricultural powerhouse. The Southeast Asia country provides significant share of 30% of the global rice export. And all the Southeast Asia country normally are the major exporter of the palm oil, rubber plantation, seafood, maize, cassava, coffee, and the tropical foods, as you can see from the picture. And Southeast Asia regions also has a agroecological diversity because the Southeast Asia regions normally has the diverse with the climate ecosystem. It support the year-round production of a variety of the crop. And in this slide, you can see the map of the agricultural sector share of the GDP. As you can see in the map, the Southeast Asia, the agriculture contributes approximately 11% of the GDP of Southeast Asia country. It's highlight that Southeast Asia region is really important to both with the local economic and global market. And regarding to the GDP from the agricultural sector in 2023, you can see in the map, in Thailand, the agricultural sector is contribute about 9%. And in Philippines, the agricultural sector contribute about 10% of the GDP in the Philippine countries and 12% in Vietnam. Therefore, in the conclusion, the soils in Southeast Asia regions play an important role in ensuring global food security through its substantial agricultural production and also with the economic contribution and engagement for the labor force in the farm activities. Therefore, this highlighted why understanding the soil issue is critical in the Southeast Asia regions. If we would like to go for the sustainable development in Southeast Asia country or Southeast Asia regions, therefore soil are the fundamental concern. Understanding the soil issue is very essential for the several reasons. First, for the agricultural production in Southeast Asia regions, normally is high dependence on the soil productivities. And also soil in the Southeast Asia country is under the variability to the degradation. Because soil in the tropical regions normally are highly wetted and also is acid with the high risk of the nutrient leaching, erosion, and also loss of the organic matters, especially in the area with the unsuitable soil management. And the third point with the climate change issue. With the climate change issue nowadays, it also can cause with the soil degradation and also can induce the expand of the soil degradation area. Therefore, with the soil degradation, it also can affect with the drought, flooding, and the sea level rise. Also, these are the drought, flooding, and sea level rise now already happened in the delta and the upland coast of the Southeast Asia regions. And then in the case of the food security, the soil in the Southeast Asia also is an issue that normally is a major, the country like Thailand, Vietnam, Indonesia, are the major exporter of the rice and other steppe food. Therefore, with the sustaining soil health, ensure the long-term food security. And for the last point, normally, as we know, soil also linked to the water and human health. If we have unsuitable soil management or if you have soil contamination, for example, with the heavy metals, it will directly link to the water pollution and also with the human health. Therefore, without the healthy soil, the regional goals on the food, water, climate, and sustainability cannot be achieved. Let's move to the overview of the soil resources in Southeast Asia. And this map shows the geographic and soil diversity across the regions of Southeast Asia landscape. As you can see, with the Southeast Asia landscape is including with the tropical highland here around. You can see with the red color around red to orange, and also include with the alluvium lowland and coastal delta. This is resulting in a widening of the soil type. It's from acidic Ekiso in the upland to the fertile Fuviso in the floodplain. Here you can see from the map. And this map also shows the dominant soil in the mainland Southeast Asia. Consists of a widening of the soil type. For example, with the Ekiso, and it's also in Griso and also Luiso. You can see from the map, from the map here, the Ekiso are found in the steep slope of Thailand and Laos, Vietnam. It's cover about 50% of the mainland Southeast Asia. And next one, for example, with the Luiso, is cover about 5% of the mainland Southeast Asia. It can fall along the big river and in the delta, for example, in Irrawaddy and Mekong. For the next one, with the Furasol. The Furasol normally we can find it in the humid regions, for example, around in Indonesia and Malaysia. And with the Ruiso, normally we found in the semi-arid regions such as some parts of Thailand and also in Myanmar and Cambodia. When we talk about natural fertility status and variability of the soil in Southeast Asia, here some example that I put some soil organic carbon stock, cation exchange capacity, and nitrogen status map. It indicates that the soil in Southeast Asia are typically low inherent with the fertilities, characterized by the low pH with a low cation exchange capacity, and normally we have the problem with the phosphorus fixation. And in this area, especially in the high rainfall and poor soil management, under the high nutrient leaks from the leaching, erosion, and also it's very high risk with the organic matter loss. Therefore, with the natural fertility status is related to the dominant soil degradation type. And in this slide, show the map of the status with the human induced of the soil degradation. And you already can see around the Southeast Asia regions, normally we have the major type of the soil degradation with the water erosion, with the chemical degradation and physical degradation. Therefore, with the physical, chemical, biological degradation, they are driven by socio-economic and also with the political cause. It's a lot of diving for that force with the soil degradation issue. Therefore, come to the key soil issue in Southeast Asia. You can see here it's consisting of first with the soil erosion. Normally the soil erosion problem we can find it in the sloping land and the area of the deforestation. And also with the soil acidity and aluminum toxicity also in Southeast Asia, normally we have it in the high rainfall zone. And with the nutrient depletion and imbalance of the nutrients, normally it's come from the continuous cropping activities. And also next one with the soil salinization, also we can find this problem in the delta and irrigated dryland. And the other issue with the loss of the soil organic matters or soil organic carbon is come from the residual burning or some area that have over cultivation. And for the some soil physical problem or some soil physical degradation, normally we have with the soil compaction, normally is due to the mechanization. And the last point is for soil contamination. It's happened from the pesticide or sometimes we find some contamination with the heavy metal from the herbal industry and agricultural activities. Come to the first key soil issue in Southeast Asia is soil erosion. As you can see from this map, the soil erosion in Southeast Asia regions, we have in the length of the moderate to high level of the soil erosion. Normally it's caused by the deforestation and also with the intensive cropping or from the poor land use practice. And the hotspot of the soil erosion here from this map, you can see the hotspot are in the upland area from Thailand, Vietnam, and also from the Philippines. And normally, I think, as you know already, with the soil erosion problem, it can cause with the topsoil loss. And also it's possible to reduce the crop yield and also it will provide with the sediment load to the river. And at the end, with the sediment load to the river, it will affect to the quality of the water. Therefore, look at the detail. The water-induced soil erosion in the sloping area in Southeast Asia country is cover about 40 million hectares. And some report represent that in the Philippines, they have water erosion cover about 10 million hectares. And then in Indonesia, the area with the water erosion is about 20 million hectares. And in Thailand and Philippines, we are in the moderate to extreme from the water erosion issue. And here in the map, you can see they report that the average soil loss, for example, in Thailand, we have about 7 to 8 tons per hectare per year. And in Vietnam, this map shows that in Vietnam, normally they have about 21 to 22 tons per hectare per year with the soil loss. And in Philippines, it's about 16 tons per hectare per year. And go to the next key soil issue in Southeast Asia is soil acidity and aluminum toxicity. As the soil acidity is possible or normally is widely spread issue in the tropical Southeast Asia country. Normally is especially in the upland or the region that we have the high rainfall. And with the soil acidity, normally it's come together with the aluminum toxicity. The aluminum toxicity is a major growth limiting factors. Therefore, if we use this kind of soil to produce with the crop production, maybe it will affect to the decreasing of the yield. In this figure, it shows the barley seeding. You can see the barley seeding if you go it in the treatment without lime with the acid subsurface soil. This one, the barley seedling root will show you the symptom of the aluminum toxicity. No? But in the case that you put some lime or you treat with the lime under the acid subsurface soil, the root will go or the root will have longer compared to the no lime treatment. Therefore, normally when we talk about soil acidity and aluminum toxicity, in Vietnam and Philippines, we can have this acid soil effect in the upland of maize and also with the cassava system. For in Indonesia and Malaysia, for the acid sulfate soil, normally they have it in the coastal zone, also is effect to the rice production area. And this slide shows the soil pH card for the world at the 0 to 20 centimeter soil depth. And you can see around the Southeast Asia country, the Aquiso and Foraso dominant the upland regions in Thailand, Vietnam, Laos, and Indonesia. And this kind of the soil type are strongly acidic soil. And next one, for the soil nutrient depletion of the soil, the high relative extent of the chemical deterioration normally affecting more than 30% of the total country area in the Southeast Asia. And it's possible to observe in the Cambodia, Malaysia, Thailand, but in generally for other regions with a negligible to light impact for the nutrient depletion of the soil. And this table show the country specific observation or some report from the research topic. For example, in Vietnam, they have some report that they found a NPK imbalance and declining with the soil fertility in the Red River and Mekong Delta. And NPK imbalance normally is come from the rice and horticulture intensification. And in Thailand, we also have some case of the decreasing of the soil organic matters and potassium in maize production area. For example, especially in the northern and northeast of Thailand. But this one also, for the decreasing of the soil organic matters, is come from the residual burning and also with the over cultivation. And in Indonesia, some research report about nutrients mining in the oil palm plantation, and this issue is come from the export-oriented monoculture depleted soil reserve. In Laos and Cambodia, normally they also face with the low inherent fertility in the upland. This one, the issue come from the poor soil cultivation under the shipping agricultural cultivation. And for the Philippines, normally some research also report about decline of the soil in zinc and potassium in the upland vegetable system. But this problem is come from the is linked to the limited to access the balance of the soil fertilizer. And then when we talk about the next key soil issue in Southeast Asia, it's come from the loss of the soil organic carbon content. For the soil organic carbon content, normally is linked to the soil organic matters. Then in the Southeast Asia regions, the decline in the soil organic carbon content is also very important one of the key soil issue. And the cause of the decline in the soil organic carbon content include with the conversion of the forest to the agriculture, and also include with the continuous with the tillage and burning residual. Therefore, normally soil organic carbon and soil organic matters play an important role in the water holding and also involved with the nutrient cycling and also microbial activities. Therefore, the loss of the soil organic carbon and soil organic matters is very important key issue in Southeast Asia. And from the map here, you can see, from the soil organic carbon content map is evidence that the soil organic carbon content in Southeast Asia regions is the length of 10 to 50 ton per hectares. And come to the soil salinization issue. This is the other issue also found in the Southeast Asia regions. And this table show you some problem with the soil salinization around the country in Southeast Asia countries. For example, in Vietnam, they found about 13 provinces along the Mekong Delta has a problem with the soil salinization. Normally, the problem with the soil salinization in Vietnam around Mekong Delta is come from saltwater intrusion and also together with the reduction of the Mekong river flow. And in Myanmar, especially, we found the soil salinization in the Irrawaddy Delta. And normally the soil salinization in Irrawaddy Delta is come from the coastal storm and also with the high tinder with the salinity. And in Thailand, with the soil salinization, we found it, the main area also, we found it in northeast of Thailand. Normally, the soil salinity in Thailand, in northeast of Thailand, is come from saline subsoil and also with the irrigation with the sea place. And in Philippines, normally the soil salinization is come from with the western coastal zone. It's effect from the groundwater salinity and also with the poor drainage. And in Indonesia, also the soil salinization is in the coastal Java and Kalimantan. This is also the cause of the soil salinization come from the sea level rise. This is some example with the soil salinization issue that also distribute around in the Southeast Asia regions. And now let's move to the soil physical degradation. Especially the soil physical degradation here is come to the soil compaction. The soil compaction or crushing or sealing is relative unimportant, but except in the Thailand and Philippines. Normally in Thailand and Philippines, we have some area that we have the problem with the soil compaction issue. And then for other country along or inside the Southeast Asia regions, normally they have less problem with the soil compaction. And then with the last key issue, soil key issue in Southeast Asia. This is soil contamination. The soil contamination normally is possible nowadays come from the heavy metals, from the microplastic, or from other hazardous waste or something. Therefore, this table show you some contamination into the soil. For example, in Vietnam, they find the arsenic and pesticide contamination in the soil. Normally, the arsenic is come from the groundwater irrigation and also is found in the Red River Delta. Therefore, they find it the arsenic and pesticide contamination in the soil. And in Thailand, we also have some case study that we find the cadmium in the soil. This is from the mining regions in Mesot province. And also in Indonesia, they find some heavy metal contamination. Normally, they have this effect from the e-waste recycling, the industry, and also with some disposal that affect with the heavy metal contamination into the soil. And in Malaysia, they're talking about persistent organic pollutants and hydrocarbon contamination into the soil. These POP and hydrocarbon is come from the petroleum and palm oil processing. Normally, is found in the zone of the palm oil processing area. And in Philippines, normally we also or someone report about pesticide and cadmium contamination. Normally is from agricultural activities, from mining, from the e-waste activities. Therefore, based on the key soil issue in Southeast Asia regions that I just discussed, we also used to concern about the driving factor of the soil degradation. The driving factor of the soil degradation normally is come from the population growth with the unsuitable agricultural practice, urban expansion, deforestation, industrialization, waste disposal, and climate change, also with the diet change. And all the diving force normally is will affect with the soil trace, with the soil organic carbon loss, salinity, biodiversity loss, compaction, also with the acidic with the acid soil, erosion, sealing, pollution, and also linked to the nutrients imbalance. These all trace will also go to the consequence of the ecosystem landscape degradation and also linked to the food with the quality and quantity of the food production. And also it will affect to the social with the climate change, with the mitigation of the people. Therefore, all the driving factor to the soil degradation, I think most of the driving factor we should concern to solve it. This is some example for the driving factor of the soil degradation. This is for the land use change. This is in the northern part of Thailand. The farmer change from the forest to the crop plantation in the upland area. And also, this is some driving factor of the soil degradation come from the agricultural activities. You can see farmer do the till in the upland area. And also farmers still do some burning residue that will be caused with the soil degradation. And also, this is also some example in the central part of Thailand in Suphanburi province. This area normally we have already with a shallow soil, but farmers still do very deep tillage. Therefore, in every cropping system or after the rainy season, we have a lot of soil erosion or the soil loss from this area. And the other driving force of the soil degradation is come from the waste disposal. That the waste disposal can come from the industry, from the community, and also from the agricultural activities that possible to cause with the soil pollution issue. And also the other driving force for the soil degradation is come to the climate change. The climate change nowadays with the extreme weather event, including with the longer or more intense of the drought or heavy rainfall, normally is leading to the flood and landslide. And also, or the extreme weather event can increase the severe soil degradation. From this picture, is represent that you can see here, if we have the 3 degrees Celsius increase, we will have about 10 month average for the length of the drought. Therefore, the IPCC warned that the drought will lead to the soil erosion, as well as can reduce the crop yields, while the flood and the landslide can destroy with the agricultural land and infrastructure. And then for the example, the last driving factor of the soil degradation go to the urbanization. The urbanization also can contribute the soil degradation by physically sealing of the soil surface. For example, when you have the city expand, maybe you need to build the new roads and a lot of construction come up. Therefore, it will affect for your soil quality. And also with the urbanization also affect to reduce the land productivities and ecological value and also with the sustainability also. Therefore, if we would like to be the sustain condition with the urbanization also should integrate also with the soil conservation into the urban planning and develop the strategy, for the urbanization issue. And now I would like to show you some case study. And for the first case study come from Thailand. And this study, normally I work together with the staff from LDD, from Land Development Department. Also, I think most of them also join in this talk now. And for this work, we would like to assess the effect of the converting field crop to the young para rubber plantation on the sloping land in the north watershed. Here, the study area, we did it in Muab sub-basin in Nan watershed, and the slope gradients ranking from 25 to more than 35. And here, the result, you can see with the young rubber, with to get intercropping with maize treatment, normally they have the high potential in reduce the soil loss during the initial state of the rubber plantation start. And also in the same case of the runoff, the runoff also observe the lowest one in the rubber plantation together with the maize treatment. And some highlight, you can see even when the young rubber only 1 years of the 1 years old para rubber trees together with the weed also can reduce some soil loss compared with the monoculture of the rubber plantation. And in the second case is in from Vietnam. In the Vietnam, normally they also have the issue with the salinity and acid sulfate soil. especially in Mekong Delta. Here you can see in the Mekong Delta is the largest concentration of the acid sulfate soil in the world. Therefore, this area also is very important area that provide with the larger portion of the rice, aquaculture, fish, and food in Vietnam. Therefore, we should find the solution or the adaptation strategy. And for this research, they report that farmer in Mekong Delta in Vietnam, normally farmers are adapting through the innovation water management. They have the automatic grade to manage the water level, and also with the with the crop diversification, and also they try to uh, mitigation with the negative impact of the acid sulfate soil, maybe with the tolerance, they choose the tolerant crop that can grow in the salinity soil or acid sulfate soil. And this is in the other case in Malaysia. They try to observe the change in the soil organic carbon stock after the conversion from the forest to the oil palm plantation in Malaysia, in Borneo. And here you can see with the result, the results show that the soil carbon stock in the upper two layer from the forest soil are significantly higher than in the soil layer of the oil palm plantation. And they also found that the soil carbon stock will increase with the age of the oil palm. However, you can see even the carbon stock will increase with the age of the oil palm, but you need to wait until 40 years old of the oil palm. Even that, the soil carbon stock still not equal to the forest plantation, the forest area. Therefore, sorry, I still have some few minutes, right? Okay, let's go. The strategy for the sustainable soil management. Then actually with the conservation, agriculture or soil and water conservation, we also can use it to mitigate with the soil degradation issue, or we can use with the soil amendment. And also we should think about agroforestry system or crop diversification. And even we should try to think about build up the capacity for the farmer training. And this is some example that I have from the using the minimum tillage and relay cropping system. Actually, this is from my PhD work. It shows that under the maize that we go under the minimum tillage and relay cropping, it has a potential in reducing the soil loss. And at the same time, the minimum tillage together with the intercropping system is also can increase the organic matters, total nitrogen, and available phosphorus in the soil at the end of the testing system. And this also some experience from my colleague in Vietnam. This is testing also the minimum tillage together with the intercropping system. Is it in Chiang Hak from Son La province in northwest of Vietnam, and also in Chiang Khoi in Son La province, northwest of Vietnam also. And you can see here on the up bar scale or up with the bar chart, is this from Chiang Hak area, and the lower one is from from Chiang Khoi. Sorry, this is the same that we observe, no? The maize under minimum tillage and with the Arcadis pintoi with the treatment number 4, they show the highest potential in reducing the soil loss. And in the case of the grain yield, we also found that if you put some soil conservation system, for example, minimum tillage with intercropping system, the main crop yield, for example, with the maize, we also still can get the high level or get the same level with the monoculture of the maize plantation. Therefore, it shows that the soil conservation with the minimum tillage and intercropping system is a suitable option also for the suitable soil management. And at the same time, we also try to assess with the economical point with the NPV, net present value for the soil conservation system. And from this study, you can see we also calculate that with the rubber plantation together with maize, with the treatment number 4 show with the highest net present value. I think this is a quite important message that we should show to the farmer when we would like to uh, transfer our knowledge about soil conservation system to the farmer about the economic benefit. They will see what they can get it, and I think is this the economic point will easily to convince to the farmer to accept the soil conservation measure system to their cultivation. And then with the minimum tillage and relay cropping system or minimum tillage with the intercropping system, normally you can see with the positive wheel, normally is also can have the good yield response. It's possible to reduce the soil loss and runoff, and also it's increased with the water infiltration and improve with the soil structure. However, we also have some negative point. Maybe the issue come through with the weed control, and farmer also maybe think about the workload, because they have to do some second crop. And also some farmer, maybe when they heard about minimum tillage and relay cropping or intercropping system, they don't know or they don't have any knowledge about this system. Therefore, we still need to fill in this gap, to fulfill the adaptation, to be success with the adaptation of the farmer. And also, maybe for the sustainable soil conservation, we also should involve with the technology and innovation nowadays. It's important that you already do some research, or you already set some demonstration site, but we also need to monitoring, But nowadays with the portable soil sensor or with the remote sensing technique, I think we should able to monitor with the soil health. And also with the precision agriculture and nutrient management, is very maybe need to concern for the other issue, to be the sustainable soil management. And also we need, or I think in Thailand, we already have the database with the GIS and digital soil mapping, with the regional soil information platform. And we also need to include with the policy and institutional support. In this issue, for the soil conservation adaptation by the farmer, I think we need to think about to integrate of the soil protection in the national policy. And also we need to incentive for the suitable land management. Even we need to strengthen the regional collaboration, for example, with the Asian country, with the FAO, or we can do something with the GSP network, and also with CERA. Uh, and also with some local farmer and also with CESRA. And also we need to robust monitoring the enforcement. And for the future perspective recommendation, I think at the end we still need to invest the soil research and innovation. Nowadays, still a lot of gap that I show you from the diving factor with the soil degradation. We still need to do the soil research and innovation. And also, as I informed you, we need to strengthen the extension service and farmer network. I think here in Thailand, we have quite a good success case via the soil doctor from land development department that they can use to interpret or use to transfer the knowledge to the farmer. And also we need to encourage the multi-stakeholder partnership. And also the other issue I think is quite important to the farmer. If we would like to promote with the soil sustainable soil conservation, farmer we need to promote with the land tenure security and community right, and also we need to demonstration with the pot or the field day on the soil conservation technique, and we need to pay very important to have the soil conservation or to put the soil conservation issue in the climate adaptation plan. And in the conclusion, normally soil nowadays in Southeast Asia are under the pressure that already I show you already here in this talk. And also we should multi-phase approach, or we should integrate many approaches together. And also the strong coordination among the government, academic side, and the farmer is very essential. And the last one with the healthy soil is mean we have the sustainable food system and resilient for the landscape in Southeast Asia. And thank you for your attention.
Many thanks, Wanwisa. It was a very enlightening presentation. So you underscored the importance of soil stewardship as a foundation for climate resilient agriculture, biodiversity conservation, and regional food security. And also you highlighted how a multi-stakeholder and a knowledge-driven approach is essential to restoring and maintaining healthy soils for future generation in the region. Thank you very much. We have a few minutes left, so I would like to have to open the floor for questions or remarks, if any, from our audience. Would anyone like to ask a question or make a remark or share based on your experience in the region, in addition to what Wanwisa presented? You can also write in the chat if you like. If not,
thank you very much, Dr. Wanwisa Pansak. One of my questions, it is very worrying that we are facing many problems. What is the most serious problem, and what soil problem should we solve first?
Okay. It's not so easy for this answer because you already can see that with the key issue of the soil in our Southeast Asia country, normally, for example, if we have soil erosion problem, you can imagine that the soil erosion problem also can lead to other soil degradation with the nutrient depletion, with the soil salinity or something. But I mean, later you can share with me also, no? I think because you are from LDD. But in my opinion, for me, I think in Thailand, for example, maybe we should think about to solve or to control or to manage it with the soil erosion issue. Because as you already can see nowadays with the land use change, It affects a lot of soil erosion. And also nowadays, it's just last week, I have a chance to visit in Nan province. And in the river, Nan river is almost with a red color. And the farmer said that this color is come from the sediment from from the upper north, because now they have some flooding issue. Therefore, for me, maybe for the first thing, we still should keep on doing or keep on concerned about soil erosion issue. And then, yeah, I think, but at the end, for me, it's linked to other soil problem degradation or soil problem issue. Yeah. Maybe with the point of LDD, maybe we can exchange also, because I think, yeah, LDD also have a lot of successful case also.
Thank you very much. It's our action to take on it.
Thanks very much indeed. Anyone else that would like to ask a question or make a remark? Okay, here there is a question in the chat. Soil acidification has become a major problem, primarily due to the overuse of chemical fertilizers. Do you have any correct method for this?
I think for this issue, I find it from some article. I mean, from this question, you would like to ask me the correct method to manage this problem, or why we have the soil acidification from the chemical fertilizer. I'm not sure.
I think it's about how to correct farmers'
Okay.
habits.
But now, for example, with the issue of the soil acidification, I mean, this is from my experience. Now we try to start to use with the soil, how to say, with the smart farm technique that I already show you. This is the point that nowadays we can have some digital soil map that we can recommend the right chemical fertilizer level or right chemical fertilizer rate. And also with the soil sensor, soil nutrient sensor technique that we try to, or my research network, they try to develop the soil nutrients probe that we hope that it will cheaper one that can monitor the nutrient status, something like that, that we can give the right recommendation for the right chemical fertilizer recommendation, something like that.
And how do you fix the problem of soil acidification if it's already in place?
Nowadays, I think, with many way, from LDD with the alarm requirements, and also now we also try with the biochar, also that we try to see is possible or it will initial to solve with the soil acidification issue or not. This is some,
Blue question.
Yes, Pat, please.
Thank you. So I would like to add up a little bit to Dr. Wanwisa for the answer. In Thailand, we actually try to promote the use of the agricultural lands. However, to use the land, you need to look at the severities of the acidity. So if your soil not go to extreme in terms of the acidity, you can use something that, like, organic matter, those kind of things can increase the pH as well. However, if your soil is kind of like very low in pH, for example, like acid sulfate soil, that the pH can go below full, for example, in some area in Thailand, we definitely recommend farmers to use the lines and to be able to use the correct the amounts of lime, we need to do some soil analysis before. However, in Thailand, we have, because I think that the person who asked the questions come from Vietnam, right? So
I see.
I probably think the same thing have been done in Vietnam as well. So in Thailand, we have some the test kits, LDD test kits that the farmer can use at the field levels. So in this one, farmer can correctly estimate how much the lime can use for their soil as well. Even the accuracy probably a little bit less than the result from the lab, but I think that would be able to use it. So Kun Wanwisa already mentioned about the biochar, the organic matters, and I add up something about the lime. And I think the best thing that we can do in terms of promoting sustainable soil management, to make sure that farmers understand the correct way to use the fertilizer, making sure that they not really like add up the acidification into their land. So those kind of things that need to go along with the promotions of using technologies as well.
Thank you very much, Pat, for complementing. I hope this answered the question of Dr. Bhuiyan. If not, please let us know. Anyone else, like a last question before we close the event? Okay, how long the lime application in soil remain corrected? For example, application of 1 ton of lime in a soil has raised soil pH to 5.5 from 4.6.
Oh, maybe คุณแพทย์
So along the lines, well, based on our experience, sometimes it depends on how intensive you use the land, and also the characteristic of the lands as well. So normally in Thailand, if you apply the correct amount to the land, that can last long for years, couple of years or 3 years. And if you look after the land wells, can go a little bit further. However, every 3 to 5 years, you need to reapply it again. So that's it. If you apply it once off. However, sometimes in Thailand, we don't really, some farmer, they don't have much money, so they don't really like put the right amount. They just try to separate into bit by bit. So that's, in this way, probably they can apply several years before plantation, before starting the growing season. So depend on how you manage on the land.
I would like to add, yeah, I agree with Kun Pat, because it depends on the type of the land also, that Kun Pat just mentioned. And for me, the others experience, maybe not only the land, maybe you can look for the alternative crop that can resistant for the acid soil. I mean, this is the other option, that Kun Pat already mentioned. Some farmer, they're quite poor, they cannot afford with the land. If you have really acid surface soil, for example, yeah. Therefore, it's still, I think it's still running for the research also, that we try to, how to say, to find some possible or the good opportunity for the farmer in each regions. I think now that we talk, we need to do we should now to concern with the precision management. Because in East, for me, I think in East region, even in Thailand, we have the different soil type characters. We have different land use. We have the different farmer management. Therefore, I think now, for me, I mean, I'm also the user with the soil digital map of LDD. Therefore, this is also, I think it's the first thing that we should use, or when we think about to plan or implement something, I think we should, as I mentioned, if we know the soil in each region, or if we know our soil well, maybe if we have some even slightly acid soil, maybe you need to apply anything, or you can still go with the crop that resistant with the acid soil condition, something like that.
Thank you very much, all. Maybe I'm inviting the CESRA Secretariat to share the contact information of Dr. Pansak, but also Dr. Tannet. Sorry, so Pat and Wanwisa. If you have any other question on what is happening in Thailand on this topic, I think they're fine with receiving your email. Okay. Because we are running some minutes late, I would like maybe to proceed with the closure, if you don't mind. Once again, we will send an email, a follow-up email. Actually, the CESRA Secretariat will send a follow-up email with the PDF of the presentation and the link to the video recording of this event. Dr. Pansak, so Wanwisa, many thanks for your presentation, and many thanks to all participants for attending this event. Before saying goodbye, I would like to remind you that the next CESRA talk will take place on Wednesday, 18th of June at this same time, so 11 a.m. And we will have, in that case, Dr. Alexis Tomasea on stage. He is from CIRAD, France, but actually working in Asia, to tell us about the BioFunk tool and in-field method to assess the impact of management practices on soil health. So we really look forward to see you all in a couple of weeks. With this, I would like to thank you all and officially close the webinar. Thank you.
Thank you very much.